So far, we've covered the heat fluxes that occur through the ocean surface. And as part of that, of course, we dealt with the evaporation and the latent heat flux, which is, of course, also a water flux of moisture from the surface into the air above. Now we're going to look at the other aspects of the water balance over the air-sea interface. So, of course, we have the evaporation, E, which we've already mentioned, and we also have the rainfall, or the precipitation, falling from the atmosphere back into the surface. And so the difference between those two things in the atmosphere at any location is something called the atmospheric convergence. And that is when you have these large-scale weather systems in the atmosphere driving moisture into a particular region. And the classic example is the tropical band, where you have a whole lot of moisture pulled into that region, which then falls as rain. So in those convergent regions, the precipitation will exceed the evaporation. And in other source regions, you'll have the opposite. You'll have a net atmospheric divergence, and in those regions, evaporation exceeds precipitation. So those are the fluxes on the air side. And those different fluxes regulate the humidity in the air above the ocean surface. So what we can think about is a water balance in that region of atmosphere sitting above the ocean, bounded by this dashed box. And so as we've looked at previously, the water content, or the concentration of water, is just the specific humidity, so kilograms of water per kilograms of air. And the total column water vapor, the total amount of water in that atmosphere, is the integral over the atmosphere of that specific humidity by the density of the air. And these fluxes correspond to a change, so a ddt, in that total column water vapor. And so that water vapor is increased by convergence, bringing moisture in, by evaporation, bringing moisture out of the surface, and it's reduced by precipitation, raining that water out of the atmosphere. So that's what happens on the water side. Now let's think about what's happening beneath the ocean surface on the ocean side of the interface. So here, evaporation and precipitation manifest as changes in something we call the ocean salinity, which you would have already seen in weeks 1 to 6 when you looked at the equation of state for seawater. So essentially, if you evaporate moisture from the surface, that makes the ocean saltier because the salt stays behind, but you're evaporating fresh water. So it makes the ocean saltier. Conversely, if you precipitate moisture into the surface, that's pure water, which is diluting the salt content of the surface ocean, and so it makes the ocean fresher. So both of these things modify the ocean salinity. So in some ways, you can think about the ocean salinity as being the analog to the humidity of the air. And we can form a salt balance for the region of ocean, which we might think of as the mixed layer, directly near the surface. And so if you write that down, what you'll find is that the change in the salt content of this mixed layer, which is the seawater density by the salinity by the depth of that layer, say the mixed layer depth, so the change in time of that is the E minus P, so the net loss of moisture multiplied by the salinity, minus any flux of salt that occurs either vertically through the bottom of the mixed layer or horizontally to other regions of the ocean. And so you can see that there's this similarity or link between the moisture budget in the air above the surface and the salt budget in the water below the surface. And you can see that if you look at a plot of evaporation minus precipitation in the top here and salinity in the bottom. And you'll notice there are some similarities in the structures there. So in the regions where you have strong evaporation, so that's in these mid-latitude regions such as Australia's latitude band and similar regions in the northern hemisphere, you also tend to have strong sea surface salinity, so elevated sea surface salinity. So you're up about 37 salinity units, whereas in regions where you have elevated precipitation versus evaporation, particularly high latitudes, you see you have much, much lower salinity. So the water is much fresher in those regions. So that's just showing you this link between evaporation and precipitation and the water content of the air to the salinity of the surface ocean.